many geologists do their research using small pieces of evidence from locations that are separated by many miles. The Earth rarely gives them a perfect glimpse at what actually happened. So geologists have to interpret their understanding based on the data that they record and knowledge they have gained from countless hours of research and studying. Today, in this National Rock Channel special, we will solve the ancient mystery of the rock layers in this undisclosed location, which we speculate was once a beach. Join us in our travel backwards through time.
After weeks of research by our team of Grant, Peter, Shale, and Felix, all of which work at the National Rock Channel, we have mined through several layers of rocks and have discovered that each of these layers contain different types of rocks, as well as several events in geological history. As we are traveling back through the past, we are going to start with Layer 1, which is right beneath our feet.
As Grant said seconds ago, we are going to start with a layer that is right beneath our feet. As I said in the intro, these rock layers had to have formed near the ocean. The rock type of this layer, which is right beneath our feet, is fossiliferous limestone. The texture of fossiliferous limestone is a coarse-grained sedimentary rock with fossilized hard shell mollusks and a fine to coarse-grained texture. The environment of the formation of fossiliferous limestone is shallow marine waters. In these places, small mollusks that die sink to the bottom where they can accumulate with other fine-grained sedimentary rocks that contain lime. The composition of fossiliferous limestone is an organic enclastic sedimentary rock, meaning that this layer is composed of the fragments of shells and mollusks and other invertebrates and calcium, quartz, and feldspar. The age of this rock layer is 5.332 million years old to today. How we determined age was only the fossils of the sea snail Neptunia tabulata were found in this rock layer. Neptunia tabulata has been around since 105.3 million years ago to today, meaning that this layer had to have formed during those years. This layer also has Neptunia tabulata, but it also had the previous layer also had Neptunia tabulata, but it also had another fossil, Argopecten-gradus. Because Argopecten-gradus went extinct 5.332 million years ago, that left an open window of when this layer could have formed. Using the date Argopecten-gradus went extinct as a starting point, I concluded that this rock layer had to have formed 5.332 million years ago to today, given that this rock is near the surface and that Neptunia is still found today. Now, beneath this layer of limestone, we have another rock that helps us further our speculation that this was a beach or an ocean. Starting off where I left off, scientist Shea will continue the evidence that this location was once an ocean or a beach.
The rock type of this layer is shale. Shale is a very fine, grained, classic sedimentary rock with well-sorted and mature clay-sized particles. The environment of formation, shale is formed in a very deep oceanic water where the water is calm enough that very fine clay and silt can settle on the floor. Shale is very fine and well-sorted particles also implies the calm areas of its formation. Shale is composed of mud, clay, and silt, with tiny fragments of quartz and calcite. The age of this rock layer is 11.608 to 5.332 million years ago. How we determine this age is the layer was only one to contain Argopecten-gradus, a species of clam that existed 11.608 to 5.332 million years ago. Using this information, I determined that this layer had to have formed during those years, as this was the only rock layer of Argopecten-gradus. We discovered something more interesting. We found an igneous rock intrusion that comes up straight through this layer.
All right, follow me. Well, we came down into this mine shaft to study row 3 of our subsection. All right, so came down through that tunnel. Here's the rock we're looking for. That right there is Dolostone. All right, come on, follow me. All right, Dolostone is a very fine-grained chemical sedimentary rock. Dolostone is formed as limestone from marine deposits in tropical shallow marine environments. Later, as magnesium-rich groundwater flows through the limestone, the lime mud. The limestone is gradually formed into magnesium-rich dolostone. Did you hear that?
No.
Oh, okay, we're good. Dolostone is composed of calcium and magnesium. I think this is 105.3 to 11.608 million years ago. Oh, it's okay. This mine shaft is perfectly safe. I verified it. All right. We determined this by how the rock layer only contains Neptunia tabulata, unlike the layer on top of it, which contains Archopecten gratis. Using the date of Archopecten's earliest occurrence as an endpoint of the age of the rock layer, I concluded that this layer is between the ages of 105.3 to 11.608 million years ago. I think the rubber falling is from the tunnel. You know? Oh my god. What is that?
Peter, what was attacking you? Oh, is this your script? Okay, well, I gotta finish what he started, so, you know what. Well, it says here that there's an intrusion going through this layer. It's called a basalt. That's rock type. Well, the texture of basalt is that basalt is a mafic igneous rock with a fine-grained texture and very small crystals. The environment of formation of basalt is basalt forms near or at the surface of mid-ocean ridges. Now, the composition of basalt is that basalt is composed of plagioclase feldspar, pyroxene, micas, olivine, and amoebophile. Basalt also has high iron and magnesium content. Now, the age of this basalt intrusion is 10.0655 million years old. How I determined the age of this is that given that this rock contains uranium-234, which is a half-life of 245,000.5 years, then this rock, having gone through 41 half-lives, I used simple multiplication to deduce that this rock is 10.0655 million years old. Dang, intrusions really are cool. I wonder who's recording me right now. I only have a limited amount of time. I don't know when that thing's coming back, but I gotta talk quick. So between rows 3 and 4 and 5, which are both tilted, we'll talk about that later if I live. Anyways, we noticed that at the top of between layers 3 and 4 and 5, there was a small erosional layer, and we noticed that this erosion was caused by ice, meaning that the erosion caused some information that relates to time had disappeared. At the top of this erosion was ash from a volcanic eruption that contains lead-205. The age of this event, this erosion, occurred 259.5 million years ago. We determined this age because the half-life of lead-205 is 17.3 million years. Taking into account that this lead-205 has been through 15 half-lives, using multiplication, we figured out that this erosion occurred 259.5 million years ago.
Take this.
Oh my gosh.
They pay these actors way too much. While me, I'm just a stupid cameraman. You know, I paid my fair share to get on the spotlight. You guys, the spotlight is over. It's my turn.
I'm sorry, please don't hurt us.
Shut up.
Well, anyways, I think Mr. Shade's
Poopy
going to
face.
talk about row number 4, which is right there on the ground.
The rock type for row number 4 is sandstone. The texture of sandstone is a rough, fine-grained, and clastic sedimentary rock. The environment of this formation is formed through the sedimentation of accumulated sand, usually in the desert or the bottom of a body of water, where it's compacted into rock as more layers settle on top of each other. Sandstone is composed of rounded particles of quartz and feldspar. The age of rock layer was 449.5 to 259.5 million years old. How we determine this is we use the formation. Okay, okay. How we determine this is we use the formation date of rock 5 with the erosion date to figure out the age range.
Okay, conglomerate, row 5. Conglomerate is a classic coarse-grained sedimentary rock that has both coarse and fine-grained clasts that vary dramatically in size. Conglomerate can form in marine environments. When formed in a marine environment, conglomerate is well sorted and contains relatively smaller particles. Conglomerate is composed of the fragments of other sedimentary rocks and usually contains quartz and feldspar too. Please don't hurt me. 471.8 to 449.5 million years ago. The fossil Fossiliferous Limestone was found in this rock layer. This is how we figured out how old it was. Using the date of Fossiliferous Limestone's first occurrence and disappearance as endpoints, I determined that this rock layer formed between 471.8 to 449.5 million years ago. The tilting, there is tilting between row 5 and row 4. Tilting happens when there is an angular unconformity, which shows that the tilting in the rock, sandstone, and conglomerate happened when they were deposited on something that was not parallel. The age of the tilting is 259.5 to 471.8. I determined this age by taking the ages of the rocks because the rocks were tilted as they were deposited.
Alright, so the FBI came and rescued us after 4 hours. We were reported missing. It came out in the shaft and took that crazy guy away. He's gone now. You forgot to mention that through layers 4 and 5, which was the sandstone conglomerate, if you don't remember, there is an intrusion of granite. Now, granite is an intrusive felsic igneous rock with a coarse-grained texture. The environment of formation of granite is that granite cools deep underground slowly from magma. The composition of granite is it contains mainly 3 minerals: quartz, alkali, and plagioclase feldspar. It also contains small amount of minerals such as hornblende and biotite mica. The age of this intrusion of granite through layers 4 and 5 is 311.4 million years old. How we determine the age of this granite is given that the rock contains lead-205, which is a half-life of 17.3 million years, and having this rock having gone through 18 half-lives, we use multiplication to figure out that this intrusion is 311.4 million years old.